Okay, welcome to lesson 36. Today we are still doing two digit by two digit multiplication, and now we're going to have up to four partial products. So let's go ahead and take a look. So we're going to continue to talk about, I'm going to skip through this, and we're going to continue to talk about what we learned in the application problem. So we're going to use kind of the same application problem or problem of the day. We're still looking at Mr. Gogan's setting up those chairs in the gymnasium. But now he's decided to set up an additional row, an additional 4 rows of chairs with 35 chairs in each row. So instead now of being, let's see, originally it was 30 times 35. Now it's going to be 34 times 35. Okay, so let's go ahead. I'm going to move myself over here. And now I have to do 34 times 35. Well, I already have some of the work done, right? I'm just going to add on to my area model down here because he added an additional 4 rows, okay? Still 35 chairs in each row, but now I have 34 times 35 instead of 30 times 35, okay? I've already done some of the work. Let's go ahead and do the 5 times 4. That's pretty easy. I get 20. And then I have to do the 4 times 30. Well, I know that 4 times 3 is 12. And then if I put my 0 on the end, it's 120. So now if I add 120 and 20 together, I get 140. I already have that 900 plus 150 equals 1050, and now I just have to add 140 to that. So I have 0, 9, 1, 1. So now he has 1,190 total chairs. So see how I can, here I broke 35 apart into 30 plus 5. And here on this side, I'm breaking 34 apart into 30 plus 4. And this is where that box method that I like to call it comes into play because we're using our boxes to try to figure out the partial product so that we can solve the bigger problem. Okay, so let's go back. Let's do a new one. Let's do 38 times 43 using partial products, okay? So let me get a clean board here. And I said we're going to do, I've already forgotten, 38 times 43. Okay, so here we go. I'm just going to write it up here so I don't forget. Now, you can set your box up however you want. You can do the 8 first and then 30 and the 3 first and then the 40. I kind of just like to keep it in order. So I'm going to say 30 plus 8 and 40 plus 3. Okay, so the first thing that I'm going to have to do here is I can start anywhere I want. I'm going to start on the top row of boxes here, and I'm just going to look at 40 times 8 and 40 times 30. So I know if I take off the 0 and I just do 4 times 8, I know that 4 times 8 is 32, and then if I put my 0 back on, I've got 320. Right? And I'm going to do the same similar type idea for 40 times 30 because if I get rid of my zeros and I just look at 3 times 4, 3 times 4 is 12, and I can put my zeros back on so I know it's 1,200. Now, the first part's done. Now I have to go and look at this bottom set here. So I'm going to do 3 times 30 first. If I cover up my 0, I know 3 times 3 is 9. I put my 0 back on and I've got 90. And then I know that 3 times 8 is 24. Now I have the partial products that I can add all together. Okay, so now I can add all of this together, and you can choose to do this any way you want. I'm going to say, well, 1,200, so I'm going to do 1,200 plus 320 plus 90 plus 24, and I'm going to add all of that together. So 0 plus 0 plus 0 plus 4 is 4. Then I have 9, 10, 11, 12, 13, carry my 1. 3 plus 2 is 5, plus 1 is 6. Then 1 plus 0 is 1. I count back 3. So I know that 38 times 43 is 1,634. And I was able to solve that using the partial products, or what I like to call the box method. So by multiplying each box, so I started out, let's see, I did these two numbers and it got me here. I did these two numbers, which gave me this, okay? Then I had to do these two numbers, which gave me this. And last but not least, I had to do these two numbers, which gave me this, okay? And then I added it all together to get the final answer. All right. Hopefully, you're getting the hang of this and you are ready to practice on your problem set. So now is the time when you will stop the video and you'll go into the problem set and read the directions, and then we'll go over the problem set together. I think this is a super fun, cool way to solve 2-digit by 2-digit multiplication, and I hope that you also found it to be helpful.